look at a number and think it's, well, just a number? What if I told you that a totally ordinary looking number could be hiding a secret? A secret so weird it kicks off a whole mathematical detective story. Well, today we're diving into a fascinating little discovery from a recreational math blog, all starting with one single number. So here it is, 28,011. It looks pretty normal, right? Nothing flashy. But as one really curious blogger found out, if you just scratch the surface, you find this hidden property that is, well, it's just really, really cool. Okay, so let's get into it. To really see what makes 28011 so special, we've got to break it down, kind of tear it apart, and look at the pieces. First things first, let's just look at the digits that make up the number itself. We've got a 2, an 8, a 0, and a 1. Simple enough. Got those in your head? Good. Now for the magic trick. Let's look at its prime factors. You know, the prime numbers that multiply together to make it. In this case, it's just 3 and 9,337. Now, look at the digits used to write those factors. A 3, a 9, and a 7. Now compare that to the digits from the original number, 2801. See it? There's absolutely zero overlap. None. And that is the first really interesting property we found. Let's call it the nothing in common property. It's like the number and its fundamental building blocks, its own DNA, are written in completely different languages. Discovering something like this is pretty neat, for sure. But it immediately makes you ask a bigger question, right? Is 2811 just a 1 in a billion fluke, a total oddity, or did we just stumble onto a much bigger pattern? The blogger wondered the exact same thing. So they zoomed out, way out. They expanded the search from this one number and asked, okay, how many composite numbers, all the way up to 40,000, also have this nothing in common thing going on? And the answer is pretty surprising. It's not 10. It's not even 100. Out of 40,000 numbers, a full 1,996 of them share this property. So our number, 2811, definitely has some friends. You can really see what that looks like here. The big bar, that's all for 30,000 numbers we looked at. And that little sliver next to it, that's our group of almost 2,000. So while they're not a total anomaly, they are for sure part of a small and pretty exclusive club. But wait, because the story gets even weirder. It turns out that a number right next door, 28,009, also has this property. And it was comparing these two neighbors that led the author to find an even stricter and, honestly, more interesting set of rules. So to get this next part, we need a new term, a proper divisor. It sounds a little technical, but it's super simple. It's just any number that divides our target number evenly, except for the number itself. The really key part here, though, is that this includes the number 1. So let's do a little side-by-side. We'll put 2809 up against our original number, 2811. And this is where we'll see how this new rule creates a huge difference between them. Okay, this is where it all clicks. For 28,009, its proper divisors use the digits 1, 3, 7, and 5. None of those are in 28,009, so it passes this tougher test. No problem. But now look at our number, 28,011. Its proper divisors include the number 1. And since 28,011 also contains the digit 1, boom, it fails. That single shared digit disqualifies it completely. So what this means is that this stricter condition, having no digits in common with any of its proper divisors, has got to be way rarer. I mean, think about it. The number 1 is a proper divisor of every single number, which means any number that contains the digit 1 is automatically disqualified. This brings us to the final showdown. Of those almost 2,000 numbers that passed the first, easier test, how many actually survive this much tougher screening? The number just plummets. From nearly 2,000 candidates, we are left with just 300. That is it. This is a truly rare and exclusive group of numbers. This chart just says it all, doesn't it? Look at the massive difference. That stricter proper divisor test acts like this incredibly powerful filter, just knocking out more than 80% of the numbers that pass the first round. We've gone from a small group to a genuinely tiny one. So what do we know about this elite club of 300? Well, they've got a few things in common. They're all what you call biprimes, which is just a fancy way of saying they're the product of exactly 2 prime numbers. And as that tough new rule demands, not a single one of them can contain the digit 1. You know, what I love is how the author ends the post, not with some grand, earth-shattering proof, but but just with this. So that's it, just something interesting. And that's perfect, right? It's a great reminder that sometimes the real fun is just in noticing something cool and following that thread of curiosity. And that really leaves us with a final thought to chew on. Patterns like these are hiding everywhere, in plain sight. It makes you wonder what other strange or beautiful or just plain weird secrets are waiting to be found in the numbers all around us. Maybe even in your own phone number or your birthday. Who knows?